Okay guys, in this video we're going to talk about the discriminant and what we can do with it. So what is the discriminant? Well, we all know about the quadratic formula, and that is x equals opposite of b plus or minus the square root of b squared minus 4ac over 2a. We've been using that to solve quadratic equations, and when we do this we find the x-intercepts. The discriminant is the part inside the radical. It's the part inside the square root but not including the square root. So this is our discriminant. It's just b squared minus 4ac. And using just that bit of information can tell us a few things. So if b squared minus 4ac is greater than 0, which means positive, if that number comes out to be positive, then we know that there are two real roots. Okay, real roots, and this year we're not dealing with imaginary numbers, but we're only talking about real roots. This only tells us real roots, real solutions, okay? If it's equal to 0, then there's one real root. And you will sometimes see this referred to as one repeated root. Okay, and that's because in a problem that would give us 0, if we were to factor it, we would get the same factor twice. So we would get one real value, but you would see it as a repeated factor. So sometimes we say one repeated root. And then if it's less than 0, if b squared minus 4ac, when we do that math, if it's less than 0, which means negative, then there are no real roots. So there's 0 real roots. Okay, so it doesn't solve the equation for us. The quadratic formula gives us the x values. It gives us the x-intercepts, the solutions. The discriminant doesn't do that. It just tells us how many solutions there are. Okay, if we wanted to find them, we would have to factor or use quadratic formula. But this one would tell us how many we would expect to have. Okay, so let's look at some examples. The first part of this is really simple. Here's a quadratic, and we're supposed to determine the number of solutions. And again, solutions, I could say determine the number of x-intercepts, determine the number of times it crosses the x-axis. That's the same thing, okay? But we have a quadratic here, and so this is b, remember? There's a 1 in front here, so that's a, and this is c. So we're just going to do the discriminant, which is b squared, so we're going to put 4 squared minus 4 times a times c. Okay, because the formula was b squared minus 4ac. So I'm just plugging in the values, very similar to what we do with the quadratic formula. And now I'm going to evaluate this. So 4 squared is 16 minus 4 times 1 is 4 times 4 is 16. And of course you can do that in your calculator and we get 0. Remember that when this was equal to 0, we know that that means there is one real root. Okay, by getting 0 for b squared minus 4ac, we know there's going to be exactly one real root. So there's going to be one x-intercept from our graph, okay? So let's look at another one here. Again, we're going to take b, and we're going to do b squared minus 4 times a, which is 1 because there's a 1 in front of this, times c, which is negative 21. So you have to be careful to watch out for your signs. And now we want to evaluate this and see what it equals. So this is going to be 16. Be very careful with your signs here. Negative 4 times 1 is negative 4, times a negative 21 is going to be a positive 84. So when I do this math, I'm going to get a positive 100. Because this number that we got is positive, we don't really care what the number is, but because this number is positive, we know that there are two real roots. Again, that means there's two x-intercepts, two solutions. It crosses the x-axis twice. Okay? All right, one more on this part. So here, this is b. Again, a is 1 and c is 1. So b squared is 9 squared minus 4 times a times c. Well, 9 squared is 81, and then negative 4 times 1 is just negative 4. And this gives us 77. And so again, because this is positive, we have two real roots. Okay, so recap. If this number is positive, we have two real roots. If it equals 0, we have one real root, or we could actually say one repeated root. So just don't get confused if you see that wording. And we didn't have an example here, but if this had come out negative, we would say there was no real roots, no x-intercepts, okay? So I want you to take a minute and do this first problem. And the directions are just find the number of solutions to each of the following. So it's exactly what I did on the last slide. So take a minute and do this first one and then check your answer with me. Okay, so again, b is -3. So we're going to have b squared, and make sure that if that's negative, you put that in parentheses so that if you type it into your calculator, it gets done correctly. So this is b squared minus 4 times a, which is 1, times c, which is 15. -3 squared is 9. -4 times 1 is -4, times 15 is -60. This gives us -51, and I don't care, again, really what the number is. I want you to write it down, but I don't care what it is. But since it's negative, we know there are no real roots. You could also write 0 real roots, okay? All right, take a minute and try this one. Okay, so same idea. 20 squared, because that's b, minus 4 times a times c. 20 squared is 400. -4 times +4 is -16 times 25. This is going to be -400. And so our result is 0. And since this is 0, we know that there is one real root, or one repeated root. Okay? All right, take a minute and try this problem. Okay, so b squared, which is 2, minus 4 times a, which is 3, and c, which is 7. Okay, so you can actually type in this whole thing. So I've been breaking it down. I did this one and then I did this math. And if you like that, you can do it. Or you can type this whole thing exactly like you see it, parentheses and all, into your calculator. And if you do that, we get -80. And since this is negative, there's no real roots. Okay, take just a minute and try this last problem on this side. Okay, so we have -2 squared minus 4 times a times c. So this is what you should have, and if you type that into your calculator the way it is, you need to make sure that you have those parentheses where they are so that your negatives are appropriately done in your calculator. Okay, and so when you do this, you get 184. And since this one's positive, we're going to say there's 2 real roots. Okay, so it's just a matter of memorizing the rules. Again, if we have a negative, there's no real roots. If we get 0 for the discriminant, then there's one real root or one repeated root. And if we have a positive value, then there's 2 real roots. Okay, so we're going to look at other ways that we can use the discriminant. In this example, it says find the values of k for which x squared plus kx plus 4 equals 0 has one root. Okay? In this case, what you see is that there should be a number here, but k is there. So we need to know what can k be? What number does k need to be in order for this quadratic to have exactly one root? And so anytime we have a quadratic and we're told the number of roots, we need to use the discriminant. Again, the discriminant is b squared minus 4ac. So we're going to use this and we're going to set it up. You see that k is in place of b. So I'm going to do k squared minus 4 times a, which is 1, times c, which is 4. But we're told the number of roots, and so we have to put something over here. We have to put less than 0, equal to 0, or greater than 0. Since it has one root, this has to be equal to 0. That was on the rules from the first slide, so make sure you know those. And now I need to solve this. So k squared is just k squared, and then -4 times 1 times 4 is -16 equals 0. And that's just a quadratic that we need to solve. And you could solve it by moving the 16 over and square rooting, or this one's actually factorable, and you know how to factor, and this one factors to k minus 4 and k plus 4. So we get k equals 4 and k equals -4. And I got that by setting these equal to 0 and solving. So these are the two values of k that would make this have exactly one root. Okay, if I had any other value of k, it would either have 0 roots or 2 roots. These are the only values that make it have one root. So k can be 4 or -4. All right, let's look at another example. Find the values of k for which 3x squared minus 4x plus k equals 0 has 2 roots. Now again, in this case, you see that k is c. This is a, this is b, and this is c. But we're told the number of roots. Remember that 2 roots means that the discriminant needs to be greater than 0. So you have to know that rule. So when I plug b in, I get negative 4 squared minus 4 times a times c. But we have to set it greater than 0 because we know that it has 2 roots. Negative 4 squared is 16. Negative 4 times 3 is negative 12 times k is just negative 12k. And we want it to be greater than 0. Now this one's linear, so that's something you guys have been solving for a long time. So we are going to move our 16 over. You could have moved the negative 12k, either one. And that's going to give me negative 12k is greater than negative 16. So now I need to divide by negative 12, but you have to be very careful with inequalities. And remember that when you divide by a negative number, this sign changes directions. So k now is going to be less than. So I've divided by negative 12. Negative 16 divided by negative 12 is going to become a positive 4 thirds. So k has to be less than 4 thirds. If I made k any number that was less than 4 thirds, this quadratic would have 2 roots. It would have 2 x-intercepts. It would hit the x-axis twice. But if I made it anything 4 thirds or higher, it would have 0 or 1 root. Okay, so to have 2 roots, k has to be less than 4 thirds. Okay, so I want you to take a minute and I want you to try this problem. But this one says find the values of k for which kx squared plus 2x minus 1 equals 0 has no roots. Remember that to have no roots, b squared minus 4ac has to be less than 0. You have to memorize those rules. So take a minute and try this problem. Okay, so b is 2, so you should have 2 squared minus 4 times a in this case was replaced by k, and c is negative 1, and we want it to be less than 0. 2 squared is 4. Negative 4 times k times negative 1 is positive 4k. And so now I just need to solve it because this is linear. It's not quadratic now. So minus 4. So I have 4k is less than negative 4. Divide by 4. Now I'm dividing by a positive. This is negative, but the number that I'm dividing by is positive, so I do not need to change the sign. So I'm going to get k is less than negative 4 divided by 4 is negative 1. So k can be any value less than negative 1, and then this quadratic would have no roots. Okay, take another minute and try this problem and then check your answer with me. Okay, so in this case, we want 3x squared minus 2ax plus 10 equals 0 to have one real root. And so it doesn't matter that a is here. We can use any variable we want, a or k, it doesn't matter, okay? So in order to have one real root, b squared minus 4ac has to equal 0. So our b in this case is that negative 2a. It's everything that's in front of x. So negative 2a squared minus 4 times a, which is 3, times c, which is 10, has to be equal to 0. Okay, be careful when we square this, both get squared. So negative 2 squared is positive 4, and a squared is a squared. Negative 4 times 3 is negative 12, times 10 is negative 120. Okay, and so now I am going to move this over. So I get 4a squared equals 120. Divide by 4. And a squared is going to be equal to 30. 120 divided by 4 is 30. And in order to get a by itself, we need to square root both sides. But when we square root both sides, we put plus or minus. So a is equal to. I'm just going to leave it in exact form this time. So a can be plus or minus the square root of 30. I could do this in my calculator and get a decimal, and that would be okay. But I'm just going to leave it in exact form. So it can either be positive square root of 30 or negative square root of 30. But those are the only values that a can be, so that this has one real root. Okay, again, I want you to go ahead and try this problem. Okay, so find the value of a such that x squared plus 4x minus 7a has 2 real roots. Again, to have 2 real roots, b squared minus 4ac has to be greater than 0, and you have to memorize those rules. A is 1, b is positive 4, and c is negative 7a. So this was b and this was c. So 4 squared minus 4 times a times c, and c is the whole negative 7a, has to be greater than 0. 4 squared is 16. Negative 4 times 1 times negative 7a is positive 28a. And so again, you guys know how to do this. We're just going to get a by itself. So 28a is greater than negative 16. Divide by 28. And so a has to be greater than negative 4 sevenths. Okay, so 16 over 28 simplifies to 4 sevenths, and it's negative. Okay, so just a few more problems. This says the following equations have the number of roots shown in brackets. So that's just another way of giving us the information. And we are to determine the values of k. So here's a quadratic, x squared plus kx plus 9 equals 0. And we want it to have 2 roots. So again, b squared minus 4ac has to be greater than 0. Okay, now watch what happens in this one. And this is a special case because k is in place of b. Okay, so when k is here, and sometimes if you have a k in 2 different areas, but when we do this, we're going to have b squared minus 4 times a times c is greater than 0. But this is going to be k squared minus 36 is greater than 0. And what I need you to see, and I need you to look for this, is that this is a quadratic, because the variable is squared, inequality, which is what you learned in the very last lesson. We can't just solve these quite like we normally do. Now, this one's factorable, so we can factor it. And you should know how to do that. And we know that our x-intercepts are going to be 6 and negative 6. But remember, if this is an inequality, we have to write our answer in a special way. We can't just say that it equals these. And in order to do that, we have to consider this graph. Okay? This is our quadratic inequality. So if I look at this, and you can pretend that this k is x to look at it, but we know that it crosses at 6 and negative 6. And in this case, because that's a positive k squared, it's going to open up. So it's going to look something like that. And we are asked for where is it greater than 0. So here and here. So we actually have to write this answer as when k is less than negative 6. Or when k is greater than positive 6. So this is just like the last lesson that you learned. Anytime you come out with a problem that is a quadratic inequality, your answer has to be written in one of those forms we learned. So be very careful to look for that, okay? And if you need to go back and review that video to know how to do this, do that because it's important. Okay, I want you to take a minute and try this problem. Okay, so be careful. In this case, a is 1. B is negative k, and c is positive 4. So we have negative k in parentheses squared, minus 4 times a times c. And because we want 0 roots, the discriminant has to be less than 0. So now, this is like having a negative 1 in front of k. So negative 1 squared is negative 1 times negative 1, which is just positive 1. And k squared is k squared. So I'm going to have k squared. Negative 4 times 1 times 4 is negative 16. So what you should recognize is we have a quadratic inequality. You can choose to factor this. This one's factorable, or you could use quadratic formula. But when we factor, we're going to get k minus 4 and k plus 4. And we know from this that when I set this equal to 0 and solve, I'm going to get 4. And when I set this one equal to 0 and solve, I get negative 4. So those are my x-intercepts. But I need to consider this graph to be able to write my answer in the right way. I don't need this anymore. This is what we're looking at to give our answer for k. So because this crosses at 4 and negative 4, and since this k right here is positive, I know my graph is going to open up. But I'm asking for where is this less than 0 or below the x-axis. So that's this part of my graph. So remember when that happens, this has to be written as k is between the lower number, negative 4, and the higher one, 4 here. We're using k instead of x because we're k here, but k has to be between negative 4 and 4. So that's from our last lesson, and it's really important that you recognize when you have a quadratic inequality and that you can solve those. Okay, so go back and review what you need to. If you need to review quadratic inequalities, do that. But make sure you understand everything and are prepared for class.